Hi guys, and welcome to the next instalment of my GCSE chemistry series. Thanks so much for liking and commenting on my previous videos, it's been really helpful. As always, if you're new around here and you enjoy the content, don't forget to subscribe to the channel. Today we're going to look at movement of particles, which basically means diffusion, so let's take it away with the first slide. As always, definitions are vital in GCSE, a bit annoying I know, so I've got a definition here for diffusion for you guys to learn. Officially, diffusion is the movement of particles from areas of higher particle concentration to areas of lower particle concentration. So this basically means the particles want to spread out and they don't like being trapped together all in one place. There are 3 experiments we need to know to demonstrate diffusion, the first of which being potassium permanganate and water. Now, potassium permanganate is a bright purple colour. If we place some in a beaker filled with water, the purple colour will slowly start to spread out throughout the beaker. This is because the particles from the potassium permanganate are diffusing from areas where there are more particles, which are the purple areas, to areas where there are less particles, which are the colourless areas. It's important to remember that all particles move in a random motion, which causes them to spread evenly throughout the beaker, causing the entire solution to become a slightly brighter shade of purple. If we were to add more water to this solution, the potassium permanganate particles would spread out even further, shown by the solution becoming an even less concentrated shade of purple. This process is called dilution, and I always like to remember that by thinking of how we dilute our squash before we drink it. So the second practical is the reaction between ammonia and hydrogen chloride. Once we've set up the experiment as shown in the diagram and described in steps 1 and 2, we can see that a white ring of gas, which is that of ammonium chloride, is formed. Notice how it forms closer to the wool soaked in hydrochloric acid, which must mean that the ammonia particles are able to move faster than the hydrogen chloride particles. If the ammonia particles are faster, they must be smaller and lighter than the hydrogen chloride particles in order to achieve this greater speed. And the final experiment we'll look at today is the diffusion of bromine gas through air. Firstly, we fill one test tube with bromine gas, which is a brown colour and it also has quite a strong smell, and secure it with a glass plate to ensure that the gas does not escape. We will fill another test tube with regular air and then place the bromine test tube on top of the air test tube, with both the gases separated by a glass plate. When we remove the glass plate, we would see the brown gas, which is bromine, slowly diffusing through the air. The random motion of the bromine particles will ensure that the brown colour will evenly spread throughout the tube, showing that bromine has diffused right through the air. If we think about it, it's quite similar in effect to practical number 1 in the way that we can see diffusion in action visibly. And here ends another GCSE chemistry revision session. As always, if you've enjoyed, please leave a like and subscribe as it really helps me out. Anyway, happy revising and I'll catch you guys later.